In this video, we're going to learn about the stdarray container. And this is also a container we have seen before, but we want to explore how it works now that we know about iterators, because it also supports a bunch of iterators. This is going to be a sequence container, so elements you store in are going to be in some kind of order. And here are a few facts about this. This is a fixed size container, so the moment you create it, it's going to have a size, and you want to have the ability to change that size later in your C++ program. Elements are stored contiguously in memory because this container is also going to wrap around a row array, just like std vector. The size is specified at object creation as a non-type template parameter, so the size is resolved at compile time. You should really know this. And this container is good if you want to enforce that your collection should be of a given size. This is a good replacement for row arrays because there are some limitations associated with row arrays. For example, we can't cross-assign row arrays. And if that's something you want to do in your C++ program, you can use stdarray as a replacement for row arrays. Here is the documentation for this container. You can read this all if you want. If you go down, we're going to find a bunch of methods we can use. We can do element access using these facilities. We have a bunch of iterators. We have a begin iterator. We have constant versions for this, and we see that this guy actually supports reverse iterators. We have capacity methods. We have operations we can do on this. We can do all kinds of crazy things. And if you go down, you're going to find an example that you can try out. For now, I am going to come back to our slides and try to use this in a few examples. To use the class, you have to include the array header. And here is a simple example of how you can create stdarray objects. You specify the size at object creation. For example, this stdarray object is going to contain 10 elements. If you put in less, the rest is going to be auto-filled. If you put in more, you're going to get a compiler error. This is the setup that we have here. And we can print our collection, see the data n. We have a bunch of things we can use to access data in our container. We can go through the at method, or we can go through the array index operator or the square brackets operator here. The square bracket operator is not going to do bound checking. The at method is going to do bound checking. And if we go through the at method and try to access something out of our valid range, we will throw an exception, and it is possible to handle that exception like we do here, and everything is going to be fine. It is also possible to use the front and back methods. This is going to give us the first element and the last element. We can even go through the front and back method to change the data back into our container. This is going to work just fine. We also have access to the data method, which is going to give us access to the row underlying array. And we can pass this, for example, to a function that expects a row array, and this is going to work pretty well. We have a bunch of iterators. We can use forward iterators to move forward in our collection. We can use reverse iterators to move backwards in our collection. We can use our begin and our end as our reverse iterators, and everything is going to work as we expect here. We have a bunch of methods for capacity. For example, we can get the size, the max size. We can check and see if our collection is empty. This is going to give us everything we want here. We don't have a capacity method because stdarray doesn't really have a capacity. And we don't have much flexibility in adding elements in our stdarray container because it is built by design to have the data put in at object creation. But we have the possibility, for example, to fill the entire collection with a single value. So if we fill it with 1000 here and print the collection again, we're going to see that all the elements contain the 1000 value here. This is how the fill method works. It is also possible to swap things up, and this is exactly what we have seen before. If we swap numbers for other numbers, we're going to see that the data in other numbers is going to go in numbers, and the data in numbers is going to go in other numbers. We're going to have this situation here. Now that we know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is array. We're going to grab the template files and put them in place pretty quick. Let's do this. This is going to give us our project that we can drag and drop to Visual Studio Code to open it up. We can open our main CPP file and remove what we don't need here. We're going to need to include the array header because we need that. So let's do this. We're going to include array. We will put in our item class that we're going to be using to play with our stdarray container, together with its output stream operator and the print collection method that we have grown to know and love. And then I am going to go in the main function and put in all the code we're going to need for this lecture. If you want, you can grab the code from the resource section of this lecture and follow along, but I do recommend typing all these things if this is the first time to work with these things in your C++ programs. I realize we don't have the print row array function put in. I don't think we do. Let's go on top and see if we have that. We don't. So we are going to hop over to the top here and put that in so that our code works. And what we are doing here is really nothing new. We are creating collections here. We will try to access elements. These are things we have seen before. So what I am going to do is try to pass this through our compiler and see that the build is good. And if it is good, we will try to run this program. And we will see that we have a problem at line 207. Int R1 was not declared in this scope. I think this should be commented out because it is going to give us a compiler error, and this was something I left in by error. Let's try and build again. Hopefully this is going to make the problem go away. The problem is gone and everything is fine, so we can run our program. We can bring up our terminal window. And we can clear and run Rooster. We're going to see everything we have as output in our program. We can scroll all the way to the top and see what we did first. Let's find code 1, where we are doing collection creation and element access. We're going to create an stdarray container. We're going to give it a size of 10, and it is going to be containing integers. That's the data we have in here. And if we print it out as we do right here, we're going to get the data. This is what we have. If we get element at index 3, we will get the 4 here. And if we go down and try to use the at method and go out of our range, we are going to throw an exception, which is going to be code here. And we're going to see that access failed, and we're going to print out the reason from this exception here. So we're going to see that we are trying to access something outside our valid range. But if we use the array index operator, we will see that this is going to not give us a compiler error or even a crash, but it is going to give us something which is really junk data, which is what we don't expect. So this is a problem. You need to be aware of this. If we get the front element, we will get 1. If we get the back element, we will get the 10 here printed out. So this is what we have here. And if we change this data and print the data again, we're going to see that the front is going to change to 22. The back is going to change to 33. That's what we have right here. And we can use the data method. We're going to try and print a row array here, and you're going to see the data here. And if we go down and show the data in our collection using the data method, this is going to work because this is going to give us the underlying array. You're going to see that our data that we have in our collection is going to be printed out right here. We can go down and look at the iterators we support in our stdarray container. We can use forward iterators, and we're going to be printing data going forward. And we can use reverse iterators, our begin and our end here, and we will be printing our data going backwards. This is something we can achieve in our C++ program. We also have a bunch of methods to play with the capacity. Let's scroll up and see if we can look at this. We can get the size, we can get the max size. We can try and see if our collection is empty. We can see the data here. We can fill it with data. So for example, if we print our collection here, we're going to see that it contains this data, but we can fill it with 1000, and we're going to see that our data is going to change to be 1000 in our collection here. This is something we can do. It is also possible to swap things up. For example, numbers is going to contain this data. Other numbers is going to contain this data. But if we swap them up, we're going to see that the containers are going to exchange data, and we will have a situation like this. This is something I want you to be aware of. Another thing is that it is possible to cross-assign stdarray objects. So for example, if we have numbers and other numbers here, we can assign other numbers to numbers, and this is going to call the copy assignment operator from stdarray. So the data we have in one collection is going to show up in another. If we go down, we're going to see that numbers and other numbers initially contained different pieces of data. But after we do the assignment, we're going to see that the data we had in other numbers is also going to show up in numbers, because we have essentially assigned other numbers to numbers, and numbers has changed. This is the situation we have right here. If we go down, we're going to see that it isn't possible to cross-assign row arrays. If we try to do that, we will get a compiler error, as we see here. And if we go down, we will see that it is possible to create std arrays of custom objects. Here we will reuse our item class, so we will create an std array of items. We're going to default initialize this, and this is going to call the default constructor for each item slot we have in our std array here. If we go down, we're going to see that default constructors were called 5 times. So 1, 2, 3, 4, 5 times. This is the case here. And if we go down, we will print our data and see that our collection contains zeros. So these guys were default initialized, but we can fill our collection with items that contain a 5 inside. And if we print again, we will get this output here. This is something you need to be aware of. This is really all I had to share in this lecture, showing you different ways you can play with the std array container. Std array is going to be using a row array under the hood, but it is going to enforce the size to be constant. The size is not going to change. If you try and put in more elements that can fit in the container, you will get a compiler error. If you put in less than 10 elements, the rest are going to be auto-filled, and they are going to be 0 all default initialized. This is something you need to be aware of. We are going to stop here in this lecture. In the next one, we will start and learn about associative containers, and these are containers that support key and values that we can store in our container. The containers we have seen so far are sequence containers, in that they allow us to store elements in some kind of order. 2 of these containers while using row arrays under the hood, so they support random access iterators. The other containers we have seen are for the list and the list, and these containers don't support random access iterators because they use pointers to move from one element to another. We also had a chance to look at the deck container, but this doesn't use a row array under the hood. It has some way to organize the data so that we satisfy the requirement for the deck container. If we go to the documentation again, we're going to see that the design principle for this collection is to allow fast insertion and deletions at both its beginning and its end. And I don't really know how it is organized under the hood, but you can research on that if you really are interested. For now, I am going to stop here in this lecture. In the next one, we will start and learn about associative containers. Go ahead and finish up here and meet me there.